Hello everyone, my name is Danielle Wolfert and I am going to present some insights on SPL extraction process that we had by revisiting the ArgoUML to ArgoUML SPL case study. The co-authors are Javier Martinez, Wesley Assunção and Eduardo Figueiredo. Okay, so as you may know, it's usually the case that software product lines are developed when there are problems to effectively create variants from a monolithic system, or from existing variants created with clone and null techniques, especially when the maintenance of the family of variants becomes challenging. These are the moments when companies want to embrace the promise of systematic and planned reuse. But in this transition, the extraction of the SPL is acknowledged to require certain high upfront investment. In this research field, every year new automatic approaches appear to support the reengineering activities, but generally we lack evidence about how cost-effective they are. We lack baselines for comparison and baselines measuring the needed effort. In the literature, we don't have much information about the process and the effort required for extractive adoption. From all the industrial case studies in the SPL catalog, only those contain information about effort and people involved. This can be explained because of confidentiality issues and that it's more common to find just metrics about the final SPL and not about the process. This was the case also the original publication of the ArgoUML extraction, as they focus on giving a snapshot of the SPL metrics after the extraction, but not about what happened during the extraction. To briefly introduce ArgoUML transition for those who had not heard about it before. ArgoUML is an open source tool mainly for creating UML diagrams. It's implemented in Java and it has a relevant size of around 120,000 lines of code. As an academic project on extracting SPLs, ArgoUML was selected for its size and because it had features with a clear cross-cutting behavior. So as the idea was to select a case study close to or representative of a possible industrial case that took ArgoUML. In this process, a total of 8 features were extracted, and 2 of them with cross-cutting behavior with respect to the other 6. They used the notative approach to implement SPLs during the extraction, so basically, they added variability-related annotations in the source code. These kinds of annotations are like if-def in C code. You annotate fragments of code or complete Java files with the feature conditions. In this example, this fragment of code will be removed if we don't select the activity diagram feature. Our contribution is to describe the process in which ArgoUML was transformed into ArgoUML SPL. Our insights can be a source of reference for companies and practitioners willing to re-engineer an existing monolithic system into SPL. Practitioners can then be familiar with our re-engineering process and how it was conducted. We also made the dataset publicly available for extractive SPL adoption research, and as an illustrative and comprehensible example for industry. The insights that I will present next are related to the following question. How the ArgoUML source code changed during the engineering process, with an emphasis on the during and not much on the final result. How was the version control system used to conduct the engineering process? What were the organizational aspects associated to the engineering process? And what were the problems found? Let's start then with the first one. we collected information from the version control system to understand the transition. This figure shows the change in the repository where we observed that, since the first commit in 2010 to the last one in 2014, we worked 2 periods. The SPL extraction itself with 135 revisions commits, and the SPL maintenance with only 21 sporadic commits. In this graph, the horizontal axis represents the revisions of both periods, and in this case we synthesized information about how the total lines of code of ArgoUML SPL are either part of the core, or if they belong to features that were made optional. We can see then the progressive evolution to create the variability-rich code, from the first commit where variability annotations were added until the final snapshot where around 1/4 of the source code belongs to optional features. As you can see, we provide different viewpoints from the transition. In this case, we wanted to know how they use the version control system, so we create this figure from the SVN repository. Feature-specific branches were used before merging. In those branches, they added the variability annotations for the target feature. We can also observe that features were extracted in parallel. For example, sequence diagram in parallel with use case diagram, and collaboration diagram with deployment diagram. For the other features, we found no evidences in the SVN about feature branches, but the developers confirmed that it was the case that they followed this process for the first 4 extracted features as well. The team was small. The main committers were 2 developers, one of them responsible for 6 features, and another one for 2 features. The developers were supervised and advised by 2 experts on SPLs acting like product managers. And then, in the maintenance period, 2 people contribute variability-related bug fixes and variability metadata. Providing insights on the team can help to understand the effort and time that was used, which is our next topic. For each of the features, we measure the time from 2 dimensions. First, the range of the revision is the repository since a feature started to be extracted until the last change, including revision to its features interactions. And second, the dates from this revision range are used to calculate the number of months. This table summarizes this information, including an analysis of the activity on the trunk for the feature under study. The lines of code change related to this feature or one of their feature interaction during the revision range. We can see, for example, that for activity diagram, with around 6,000 lines of code, almost 6 months were needed until the extraction of the feature was stable. As another example, we can observe how the sequence diagram feature was extracted in a branch for revision 80 to 88, but that there were changes in the feature after the feature branch was merged with the trunk. The last change during the extraction period was in the revision 123. But also there were changes during the maintenance period. The dataset that we provide can be used to make further analysis. The following number cannot be generalized, but these are examples of arrays in this specific case study. Each feature took around 4 months, and for each 1,000 lines of code, we were annotated as variable. It took around 0.7 months. Regarding our insights into errors introduced during the process, we had 2. One is that, as with any complex software engineering process, variability bugs exist. In our study, the use of a tool was helpful to discover some of them, and they were fixed. The other one is that we identify cases where typos in the feature condition of the annotations create bug states of the SPL. To support these kinds of variability consistent checks will be desired as there was no validation of correct or incorrect features IDs in the annotations. As conclusions, we provide insights on the engineering process from different perspectives: source code evolution, organizational aspects in effort, and problems found. This way, we have more complete characterization of the process and not only about the final state. We also noted that automated tools to help to monitor and verify the state of the SPL during the transition will be desired. As further work, we are looking into other transition processes with diverse characteristics, so we can provide more clues for effort and cost estimation. Thank you very much for your attention, and I will be happy to answer any question you may have.